Hello everyone. My team and I decided that for our final project for EGR 305/ME 522, we would make a tank in CATIA. It has many functional kinematics, and we will now show you our project. So for my part of the tank, I was in charge of the body. As such, here is the top of the tank where the turret that Lorenzo is making will be uh, placed on. The tank here was made using GSD on a few of the sides to get the curvature approximately where it needed to be. The overall shaping was not that uh, annoying using GSD, whereas with part design, there would have had to be a lot more pads and cuts done instead of just kind of getting the shape where it needed to be and with the slope moving accordingly. So that was a very helpful way of using the shaping tool from there. Once the general profile was made, a simple shell took care of the bottom of the part, making it the proper thickness for where it needed to be as a tank. Of course, it needs to be pretty thick. And yeah, from there we move on to the seat. So this seat was made almost entirely using GSD. Basically, I wanted to give it sort of a curvature of what an actual seat would be for someone that would be inside of a tank for multiple hours. Try to make it as comfortable as possible. The material I applied, that's not shown here, but will be shown in the tank, is actually leather because, why not get fancy? Overall, the shaping using GSD involved quite a bit of extrusions and uh, a bit of surfacing, but it's in the end the hardest part of the whole project was the full tank assembly. For this, I was actually in charge of assembling the vast majority of the tank, due to the fact that I was in charge of the body, the mounting of the everything short of mounting the treads I put on the body. If it says a any sub assembly that was made by my group mates were attached by me, the scaling process, the adjusting process was a difficult one, but slowly but surely it got done. The textures were also done uh, by each of us, but the process was found by me. I made the texture that we used for the whole tank, using an image of some tattered metal, kind of to give it that nice effect of war torn effect.
Hello, everybody. My name is Lorenzo Audisio, and I was in charge of creating models for everything that is above the main body of the tank, which includes the main turret housing, the cannon, the machine gun stand, the various hatches, and the firing slash loading mechanism located inside the main turret. Let's take a look at the model that I created. This is what it looks like. It has been fully textured to look, old and rusted with a military green, along with some nice shark teeth stickers on both sides of the turret for added effect. So now, if I start pulling the different parts to show the assembly, you could see how they all fit together. So there is the main cannon, the cannon cover that goes between barrel and the turret housing. There is the firing slash loading mechanism, where I have also created a sample tank shell along with the warhead and the casing, the loader shield, along with the side hatch, the gunner slash loader hatch, and I move this. There is also the operator hatch along with the seal that goes between that and the housing. And then also the machine gun which I actually pulled in from a previous project because, well, it looked nice. So now, talking about the actual parts, the most annoying part to model was definitely the main turret housing. A lot of GSD had to be used in order to get this to look that the way it does, mainly because of its very odd shape. Part design just wasn't going to cut it. So I used sketches for all the flat surfaces, such as this one right here, the one in the middle, and the circles on the bottom. Points and lines for the slanted surfaces and the curves. And then I finally used multi-section surface to join it all together and fill to close off the top and bottom. The rest of the parts were fairly easy to make. Most of the circular parts are created using sketches and revolve, except for the cannon cover, which also required GSD. That's simply several planes with guide sketches and curves that go from one end of the cover to the other, and then join them all using multi-section surface. The machine gun was actually, as I said before, a previous project that was brought in and saved as a part instead of an assembly. So that simply had to be joined together using Boolean operations to make it one single movable part, and then simply scaled down to fit the actual size of the tank as we see here. So now if I update it again, we're back to having this. This will fit on top of the body, and so the kinematics can be applied to it, where the cannon can move up and down and the turret can move side to side and take aim, and that would be it.
Hello, my name is Pablo Vilches, and I have been responsible for the creation of the suspension and the sprocket of the tank. The sprocket is the driving gear of the treads, and the suspension is the part which absorbs the bumps from all the terrain. I think the best way of understanding how these parts have been done is through CATIA, so let's go. Here we have the sprocket assembly. As you can see, it has some resemblance with the photo. This part with this part. It might look complicated, but it's not. You can see here we disassemble a bit. Here's bolt. It has 13 bolts. We are not disassemble all of them because it would take me some time. The sprocket and the sprocket hub. If you want, we can get a bit more detail on the sprocket. You can see here, it's not very complicated. It's pad, hole, pattern, but the most challenging part here was making it realistic and that it would work with the kinematics of the threads. So let's continue with the arm assembly. As you can see, it has again some resemblance with this part that we are trying to do. Again, it's not formed by very difficult parts, but it has some things that I have learned from here, for example, the spring and other parts. If we disassemble again this just a bit, it's rollers, which I can explain later. Another roller, here's support. This is the part that I will explain more in detail, a shock absorber and some pins. If we get to the roller, again, some cover, some bolts and nuts, and I'm not gonna disassemble all of them because it could take me all the 4 minutes. Nuts. This is the roller, and now let's get into the most interesting part, which is the spring assembly, which is here. As you can see, 3 parts, 2 supports, and the spring. And this spring is very interesting because it's not like a regular spring that we are used to see. If we get into the spring, it's called volute spring. And it's formed, if we define the helix as our working part, we can see it has a taper angle, which is the most interesting part of this spring. If we go out again and you define the material, let's define object. Here, the other difference between a normal spring is just that the profile that follows the helix is not a circle diameter, it's rectangular. And these are the differences between a normal spring and a volute spring. In addition, if we want to apply textures, that is something I have learned in this project, we need to add material, chessboard. When we get in chessboard and go to properties, we can select any texture that we want from a picture that is over here. Scale it, position it, and whatever we want to do. These have been my parts from the tank. I hope you enjoyed, and now another colleague from my group is gonna keep up with this very nice project.
Hello, this is Jefferson Talbot. I will be talking about the differential and the tracks of the tank. Here you see the differential. The purpose of the differential is to divert the power from the transmission into differential torque to drive the sprockets in the tracks. The input of the differential is this pink helical bevel pinion gear. The outputs of the differential are these blue slotted shafts. These blue shafts connect to additional gearing, and these gears are then connected to the sprockets in the tracks of the tank. A couple other inputs are these green geared shafts. They are the control input for the driver of the tank. Each green shaft is fixed to a brake disc. When the driver squeezes the trigger on one of the direction control sticks, the brake disc actuates and causes the green shaft to slow down or stop. The shaft that is free to rotate experiences greater torque, driving the track sprocket and turning the vehicle. Just give this a little bit more of a overview. Alright, we'll now look at one of the more difficult parts to make, which was this helical bevel crown gear. The most difficult part was coordinating the geometry to mesh with the pinion gear. Both the crown and pinion gears were made from the same base part, so the pinion was a bit easier to deal with after having made the crown gear. We'll now look at a cross-section of the differential. You're able to see the interaction of each gear with one another, and can see how the shafts are separate from each other. We will now move on to the track assembly. This is one out of the 2 tracks for the tank. There are 72 track shoes in each track, and each track shoe has 10 parts. I've set this up to simulate kinematics, but attempting to simulate 720 parts moving around a guide shape just makes CATIA sad, so I won't do it for this demonstration. We'll now look at one of the track shoes. Here is a track shoe. As you can see, there is a ledge and a spike. These help the tank grip into the ground. On the other side, there is another spike. This helps guide the tank along the track and keeps the track from slipping out from underneath the wheels. That was a demonstration of the differential and the tracks.
So for the conclusion, we thought we would take you around the tank and show you a couple of features. So first, the treads, all-terrain, of course. In addition to that, a tank this size needs a lot of power. It is for this reason that we have equipped this tank with the engine straight out of a Bugatti Chiron, as you can see there through the engine hatch. Now, of course, it wouldn't be a tank if it didn't fire. So we have set up the kinematics for the firing mechanism, and now we will show you how our tank fires. Lastly, I would like to discuss, as part of the conclusion, one final piece of kinematics that I have not shown, and that is the treads. So, due to the way that we model the tread and how Jefferson would say, more complexity is always better. Um, but apparently not for this case. So here are the treads. Each one of the shoes is made up of a lot of different parts, and so when we actually try to run the kinematics, it causes many of the computers to crash. The only computer that was able to actually get the treads rolling was Jefferson's computer, and even at that, it didn't have anything else from the tank. And the main problem is that even then, due to it having approximately 500 moving parts, it actually was not able to move at a reasonable rate for us to showcase it as much as we would love to. We did get it working, but it just is not feasible for us to show it to you guys as part of this video. It runs very slowly, it barely just ticks by, and it is prone to crashing the computer due to the capability of CATIA.